Hey everyone, Radhe Radhe. My name is Ayan Pasha, and today we'll be learning about another important topic. In the previous video, we took an analogy of comparing our partner or our mother. She might have gone to her parents' home or somewhere else, and she's busy at the moment, so we are missing her. So in that way, we try to explain about the load balancers in our computer science domain and the whole cloud native and Kubernetes as well. So in this example we'll be discussing what if in the efforts that we put to split up the whole traffic or into various different activities failed, and all the traffic is now moving towards one particular service and our server has crashed. It's overloaded at the moment, so we have to apply some other techniques as well to tackle that particular situation. Let's say we took the same condition in which, let's say, our partner or our mother is at her home, is with her parents at the moment, and we are at with our father. We are at our own home, so we are missing her too much because yeah, and miss we love her. So yeah, so we are missing her. So we try to get involved in some other techniques as well. We try to split up our attention which could be compared with the traffic. In our case, we try to split up the whole traffic attention by getting involved in different activities, which could be either by with the help of gym or sports. I play badminton and yoga. So let's say we try to get involved ourselves in the badminton, yoga, swimming classes, and various other activities as well. We try to explore, go out with our friends, and try to spend more time with our family. So that all failed, and now our server is crashed. It's overloaded at the moment. So like yeah, so our server is crashed. We are getting the 5xx status code, 500 codes and all those status codes that the server has crashed. The problem has been detected at the server side, not at the client side. Maybe because the server is crashed, or maybe it's been retrying again and again, or the memory or the CPU and other resources aren't enough to handle that much amount of traffic that is actually caught at that moment, at that particular moment. So we can figure out that particular status of our service maybe by monitoring or by observability. Like monitoring could be was compared earlier with our behavioral changes, which could be observed with the help of our parents or by ourselves either. So what could be the like how can we solve this particular thing? What could be the troubleshooting part? So let's try understand about the troubleshooting as well. So troubleshooting we can either send alert messages through various other, like the various plugins as well that are included in the whole Kubernetes domain, through the plugins or various dashboards as well, or other the tools and these CLI and other softwares that are included that are helpful in, like, we usually combine our cluster with all those plugins or APIs, and then whenever a problem has been detected in our cluster, whether it is about the traffic overloading or some kind of an attack, cyber attack by some other organization, there's all of those particular messages or the alerts has been sent to the admin or the particular person who's responsible for handling our whole cluster. So we can either send alert messages, and we can send messages to our mother or the partner lover who's who's far away at the moment from us. So we can send messages to her that I'm missing you, so she can reply if she's free at the moment. She is not busy at the moment, so she can reply, and our the whole problem can be solved. 200 status code can be attained at the moment, and success code could be found in our cluster. So either that is possible. Otherwise, scale up our resources. We can scale up our resources. The more CPUs and memory is required to handle all those particular requests, which is again like possible if a response had been attained by the mother or lover in our case. or the auto scale auto healing part. If we aren't getting any particular responses, then we can either wait for our responses, or we can, you know, our divert our whole mind by sleeping or other activities either. So it can be considered as an auto scaling or auto healing part. And the another one is the edge case. Fourth one is the edge case, where we are waiting to get certain messages, but we haven't got so far. So we are, you know, we'll try to we'll try again and again to send all those particular messages, or we'll at least try wait. And our stack, the request stack that is actually included in our cluster, will keeps on getting increased. All those particular requests, like we try to send the request but we haven't got any response at the moment, so we'll try to send again another one. So our whole stack of you know, the requests is getting increased again and again. And yeah, if we get any particular response from the other party that we've been you know, expecting, then the 200 status code can be achieved. What could be the response in our cluster, like in our Kubernetes cluster mode? Like we try to contact the admin who's responsible for handling of all those particular you know, our cluster. He's not responding at the moment, but as soon he got the you know, the message, and he tries to get on to that particular problem and tries to solve those particular problem. And as soon he gets success, like either CPU or the memory resources can be handled to that particular service who's responsible for handling of all those particular traffic at that moment, or else our network policies can be increased, can be improved at that moment. Network policies usually plays a very important part in this whole scenario, setting up of our it can be major rules, like in our case it could be major rules, like regular messages or calls can help in this scenario. Otherwise, from the Kubernetes perspective, we can like label and draw some network policies as well, like any particular service that's of a certain memory will be diverted to this particular traffic service. And if that service is handling those many requests at the moment, then it would be diverted to this service, or any update or, you know, the deletion of any particular service in our whole cluster, it could be managed through the network policies that we have laid earlier while defining our Kubernetes cluster, or either afterwards as well. It could be changed. It doesn't matter about the timing of the like the scenario or part when we describe about our network policies. So yeah, that's all. Yeah, Radhe Radhe, Jai Siya Ram.